An integral can be improper because one or both of its bounds is infinite, or because one or both of the bounds would cause a discontinuity in the integrand. The other option is that there is a number in between your two bounds that would cause the integrand to be discontinuous on that interval of your bounds. So in this example, we have our bounds are from 5 to 10, and we see that at our lower bound, when we sub in 5, that would give us a 0 in the denominator. So for our reasoning of why this integral is improper, we would say that it is improper because of a discontinuity at x equal to 5 in the domain. And by domain, I just mean the domain of the bounds. So first step whenever you have an improper integral is to rewrite it using proper notation. So we will begin by writing this as the limit as t approaches infinity. As t approaches 5. And because this is a one-sided limit, we are approaching 5 from the right, because the upper bound is larger than 5, so we're coming at it from the right-hand side. So we put our plus sign, and then we replace the improper bound with t. So this becomes the integral from t to 10 of x dx over x squared minus 25 quantity squared. So if you can do a u-sub in your head, this is a pretty simple one. That is totally fine. I'm going to go through the u-sub just to show you how you would change your bounds when you're doing a u-sub. So we'll let u equal x squared minus 25. And then du is 2x dx. And dividing both sides by 2, we have 1/2 du is equal to x dx. To change your bounds, start with our upper bound. When x is equal to 10, we have that u is equal to 10 squared, 100 minus 25, which is 75. And for our lower bound, when x is equal to t, we have that u is equal to t squared minus 25. Okay, so writing our limit now, in terms of u, we have the limit as t approaches 5 from the right of the integral from t squared minus 25 to 100 up to 75. And then in our numerator, in place of the x dx, we have 1/2 du. And in the denominator, in place of the x squared minus 25 squared, we have u squared. And this is equal to the limit as t approaches 5 from the right of negative 1/2 u to the negative 1. And we're evaluating that from t squared minus 25 to 75. So that is equal to the limit as t approaches 5 from the right of negative 1/2 times 1 over 75. And then minus a negative becomes a positive, 1/2. And we would have 1 over t squared minus 25. And then to evaluate this limit, we look at that denominator we see with t squared minus 25. As t is approaching 5 from the right, t squared minus 25 will always be positive. So we're getting a number very, very close to 0 in the denominator, but a positive greater than 0. And so that means that as the denominator is getting very, very close to 0 from the positive side, that the entire limit goes to infinity, to positive infinity. And so then anytime you have improper integral like this, you want to make sure that you finish with the conclusion. So in this case, we would say the limit from 5 to 10 of x over x squared minus 25, quantity squared, dx diverges to positive infinity.